Okay, guys, in this question, we are going to review probably the hardest question on the test. Usually, a lot of people are having difficulty with it. And it's no wonder because it is a hard concept, but it is nevertheless one of the most important results in statistics. So you can't just discard it and not cover it. It's actually super important. And that something is central limit theorem. So first of all, every single one of you should have central limit theorem written down on your note card because you know in a nice situation where you can use one note card on a test, and central limit theorem should for sure be a part of it. So what it should say is that regardless of the distribution of the original data, when we look at the distribution of the sample mean, if the sample size is large, the distribution of the sample mean becomes approximately normal. So as the sample size grows and keeps increasing. So why it's called limit theorem? Because this is really in the limit as n approaches infinity, n being your sample size. Okay, so which option says that? So first of all, it should be sample mean. Please write this on your note card. It's not population mean. Population mean cannot go anywhere. It's just one number. It's the sample mean that could approach something. Okay, it has a distribution because there's different sample means depending on the sample, but there is only one population mean. So which one says the distribution of the sample mean becomes approximately normal? So I think it's this one. This is incorrect because it says for any value of n. That is not true. So if you have small values of n, your distribution might still be skewed if the original data is skewed. But large values of n, it's going to be approximately normal. Okay, so the next thing you do is look at what they gave you. So look at what they said, mean is 29. So a lot of people do not understand what's what here and what do I substitute in the formula. Okay, so look at what it says. So the mean of 29, we write this using symbols, which I hope you know, but maybe you don't. So let me write it. It's mu, which is the population mean, equal to 29. That's what they gave you. Okay, then they also give you the standard deviation of 2 pounds. So what is that? Well, this is the same as sigma. So you should know that. If you don't, write it on your note card. Mean is mu. Standard deviation S sigma. Okay, and then sample size here is 43. This is n. So hopefully if you know which is mu, which is sigma, which is n, you can substitute in the formulas, okay? Because a lot of times people just put random numbers in there because they don't know the notation. Okay, so we're gonna say, okay, so what can we say about this distribution of the sample mean weight of 43 packages? Now, this actually comes out of what's called rule of thumb. And the rule of thumb says that if your distribution, if your mean is based basically on 30 or higher number of observations, if you're averaging at least 30 observations, you can assume that the sample mean has normal distribution approximately. Okay, so we're going to say because 43 is greater than 30 that we can assume that the distribution is approximately normal. By the way, this answer, as long as your sample size is at least 30, should not depend on what they told you in the beginning. So in the beginning, they could say that the weights of packages have uniform distribution or exponential distribution or any distribution, skewed left, skewed right, whatever. It doesn't matter to central limit theorem. It'll be the sample mean distribution will be approximately normal regardless of what the population distribution from which you're sampling from is. So here, please do not choose anything else as long as the 43 or whatever is your n is 30 or higher. Okay, so for the mean, we're using the formula right here that mu of x bar, and this is mu of x bar right here, is equal to the mean. So whatever that mean is here, 29, that goes in here also. Very typical mistake over here for the standard deviation to just say, well, its standard deviation is 2, so I'm just going to put 2. But that's incorrect. 2 is standard deviation for one item. You have the mean of 43 packages. So standard deviation of the mean, which is this formula right here, if you can look at it right here, this is your standard deviation. Okay, so it's the original standard deviation, which was 2, divided by square root of how many packages you got, which in this case is 43. So this would be 2 divided by square root of 43. Okay, so we got that out of the way. Now let's use Desmos. So let's go ahead and open Desmos. And I'm just gonna reset it and delete all of the stuff. So let's just enter a new distribution. So we're gonna click on the plus sign. We're gonna go to inference. We're gonna, under probability distributions, use normal because we know this is approximately normal. And the key part here, which a lot of times people do not do, and that's why this question is the hardest on the test, because literally half of my students, which is driving me absolutely insane, would put the mean here of 29 and standard deviation of 2, and they think it's great. Well, I am not giving you any partial credit. If that's what you put here, you know, sorry, but like not sorry. So you should not put 2. The reason why they're asking you this is because that's what you should put in here. Because the distribution of the sample mean is not going to have standard deviation of 2. You have to divide it by the square root, okay, of the sample size, which in this case is 43. So now I got it. Now I have that, and I click create distribution. Okay, so I see the distribution. I'm going to expand the cumulative probability menu. And then I want to know what's the chance that the average weight is at least 28 pounds. So at least is right. So I go to right. I enter 28. And I guess it's a really, really big chance. Okay, so I think because it shows me 4 decimal places, I'm going to go ahead and click on the snapshot. And it'll probably be equal to 1. Okay, so close to 1. So it's 9999. We'll see if it accepts that. Sometimes there is just little rounding problem. Okay, and then we have less than 29, so that would be left. And 29, that should just be 0.5 because that's half of it. Okay, so let's take a look.